Hello everyone, today we are going to solve the another code forces problem. That name is against the difference. So first I will read and explain this problem. Uh, we define that a block is an array where all the elements in it are equals to the length of the array. Means all the elements are in it are the equal to length of array. Here all elements are 3 and the length of the array is also 3. That's why it's called a block. 1 is also a block, and is given 4 is also, but these are not block because length of array is 3 and the elements in it all is 1. And this is also because there are different elements in this array. So an array is called neat if it can be obtained by concatenating of an arbitrary number of blocks, possibly 0. Means we call a array neat if uh, after concatenating, means if we concat or join multiple block of elements, then we called the array as neat. Means if we combine multiple blocks, it will become a neat array. Okay, and here we have given an array A consisting of n integers. Find the length of longest neat subsequence. We have to find the length of the longest neat subsequence. Okay, so each test case contain multiple is now first and integers. So how we are going to solve this problem? Mm, just think in a two ways that if talking about maximum minimum, it can be either greedy or DP approach. But if first we will go through greedy approach, we will try to uh, take the maximum element always. Then it can be possible that if we try to take the maximum element waiting for this, and we are ignoring if there are one element present in our array after each maximum, then we are going to miss these one elements. And in the finding of the maximum, like this set should be repeat 8 times, 1 2 3 4 5 6, let me get 7, and it's not repeated 8 times, 8 is missing. Then we can definitely see that the greedy will not work on this problem. So the last resolution will be go with the dynamic programming approach. So after seeing some test cases, we can see it's a linear DP problem. Means uh, we need to select a AI element and see if it can be included or not included. Okay, so this way we are going to solve our DP, if it can be included in our neat subsequence or it cannot be included. So our DP I should be look like this: DP of I equals to max of DP of I minus 1. Okay, it's for the not including AI element. Or if we're going to include that AI element, means the length, means we are selecting the AIth, means we are selecting a subsequence of length AI that we will have block, means the block is of length AI. Okay, then something DP of X. Okay, this is the our length of a block. and this whole is the when AI is included. Okay, so I will explain this part first. What is dp of x? uh, X is my integer index before aith first starting from the block path. Block path means, let's say if we have 3 3 3 3 3, this is of length 5. Then if we uh, if we going to choose our x, then it should be length 3, okay, is index from 0 1 2 3 4 5. So index is from the uh, this first occurrence -1, so x will be here 2. Okay, because this is the first occurrence of our block, this is going to be our block because it's of size 3. Okay, so here the x will be 2 because we are going to choose x uh, before the first occurrence of that element in our block. So here the first occurrence is at third index and 3 minus 1 is 2. So now I will show you my solution. Here, first I have taken the input of my array from the 1 base index, and after initializing a dp all the values from 0 because length, if it does not cannot find any neat subsequence, then the 0th will be our ideal answer because size of choosing 0 is always 0, means if there is means 0 size is 0 always. Then moving towards the dp calculation part computation, and here I am created a map of integer as a key and vector will store my index, means this index repetition. Then started loop from I have included uh, for the AI element I have included that index, and this is the not including that element, means AI is not included. And if the size of my map is less than AI, means we cannot form any block. And if we include AI to our DP, then answer we are going to find this X element. Now the X will be something like M is our map. So in the map element map of AI, this will give me the vector, this term only. This term give me the vector, and we finding that vector size minus the element size, this will give me the AIth index last from the right hand side. And means from the right hand side, if you see in this uh, from the right hand side, from this side, I'm minusing the whole size of the vector v dot size minus 3. This will give me, if this is size of 1 2 3 4 5, 5 minus 3, 1 2 3 4 5, 5 minus 3 is 2. So here the element is vector index is 0 1 and 2. this will give me the uh, second index, and second index element uh, is 3 here. Okay, and second then this will give me the second element, and second element index we are going to find through map of a of I. So if we insert that second element, we are getting this 3 as a output. So x is equal to 3 here. In this example, x is equal to 3, and we need to find the maximum dp from x minus 1. So that's why this is already pre-computed, means assume in our previous computation. So this is our the simple dp computation. So I will going to submit this problem. Accepted. Thank you.